Hello, everyone. This is the lecture for section 1.5, transformation of functions. So now that we know what a function is, some properties behind them, and we've seen how they look like on an XY plane, so if we graph them, right, what we're going to do in this section is learn certain things that if you see it in a function, right, you are guaranteed certain things on its graph. Okay. And a lot of the course is actually going to be sort of geared toward this, that if you see something in a function, you automatically can expect to see something on its graph. Okay. We're going to start out with the basic stuff. Before this section, hopefully you guys have gotten a packet with a bunch of sort of pre-done functions, graphs, and tables for you. Okay, you can go ahead and refer to that as many times as you need to. Okay, the theory behind it, right, is what I'm going to cover right now. Okay, so in this section, what we're going to be doing is learning about horizontal vertical shifts, reflections about x and y axes. Whenever we have an odd and even function, or if something is neither odd or even. Okay, and then we're going to look at how to compress and stretch out graphs, okay, given that we have a base function of some sort, okay? So let me start first with a vertical shift of a graph, okay? So what we're going to do in this section, right, for this example in particular, right, I am going to concentrate on this function right here, okay? This is the cube root of x, okay? It has that little squiggly shape that's right there in front of you, okay? And what we're going to look at in particular is this function right here, the g of x function, which is f of x plus 1, okay? And I've got a table on the right-hand side, and we're going to sort of map out the values, okay? And in particular, I'm going to be looking at these 3 points right here. This one, and this one, okay? Those 3 points, I'm actually going to highlight them too. Bam, 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 okay? And that's going to correspond to these 3 x values right here. When x is -1, 0, and +1. Okay. All right. So if you take a look at the graph, right, we can see that the f of x values are going to be, so this is going to be f of -1, right? And according to the function itself for the graph, right, that's going to be -1. Okay. When x is 0, right, f of 0 is going to be 0. F of 1 is going to be 1, right? And those correspond to this point, and this point respectively, okay? All right. Now what we're going to do is we're going to look at this function, the actual one that we came to look at, right? Okay. What I'm going to do is this. Let's say I want g of -1. This is going to be my y value, right? According to the definition of my function g, right, this is going to be f of -1, right, plus 1. F of -1, we know what that is. So it's going to be -1 plus 1 is equal to 0. Boom. This is the value, right? Okay. Next one. G of 0 is going to be, according to the definition, right? F of 0 plus 1, and that's 0 plus 1, 1. Okay. G of 1 is equal to F of 1 plus 1 is 1 plus 1 is 2. Yay. Okay. So now what I want to do is look at this. Okay. We know we know what x values we have, and we now know the corresponding y values for g of x, right? Okay. So let me re-highlight some stuff. Okay. I'm gonna do it in blue in this time. Okay. At -1, my g of x is going to be 0. So I'm going to go ahead and grab my purple marker, right? At -1, it's going to be 0. At -1, it's going to be 0. Boom. Okay. Next one. At 0, it's going to be 1. Boom. Got it? At 1, my y value is going to be 2. So at 1, my y value is going to be 2. Boom. Okay. Oh, wrong color, wrong color, wrong color. Purple, purple. There we go. Okay. So notice what's happening. Okay. That I'm going to actually keep it in purple there. Okay. I'm going to highlight that in blue. So what I want everybody to look at is this, that it grabbed each one of these points and moved it up by 1. You guys see that? So my new graph, please don't make fun of me, is going to be something that does like this. Oh boy. Does like this. Whoosh. Whoosh. Close enough. Yeah? Okay. It grabbed the original one and moved it up by 1. That is what this +1 that's right here does. That is what that +1 right there does. Okay. So just by looking at these 3 points that were the example, right, we can sort of pick out the rest, right? We know that this was going to be, what's that going to be? The cubed root of 2, right? So it's going to be, this point right here is going to be the cubed root of 2 plus 1, and so on and so forth, right? And then same thing backwards, right? This is going to be the negative, whoops, not negative, the cubed root of -2. So this should be the cubed root of -2 plus 1. It grabs all the y values, moves them up by 1, okay? Okay, so that is the vertical shift. Let's go ahead and move on to the horizontal shift. Okay, this one's a little bit more convoluted, okay? But I do want to run through the logic for it, okay? These 3 points, I'm going to use the same 3 points from before. So this one, and this one, okay? Okay, so when x is -1, we have here f of -1, right? That is going to be -1, right? F of 0 is going to be 0. F of 1 is equal to 1, corresponding to the same 3 points. Okay. Okay. Now let's look at g of x. Let's look at the point g of x. Cool. Okay. So I want g of -1 according to the rule for g of x, right? That is going to be f of -1 minus 1 is equal to f of -2. Okay. Now, f of -2, that should be this point down here, correct? We don't have that point in particular right now. If you want to compute it, that's fine. Okay. Let's, and we'll move on. Let me skip this for now. Let me do g of 0. Okay. Maybe this one will be a little clearer. Okay. G of 0 is going to be f of 0 minus 1, which is f of -1. We know that point. That is -1. Okay, let's move on to the next one. Let's just compute these out first. Okay, 1 minus 1 is equal to f of 0, which is 0. And let's go ahead, now that we have an order, actually, let's go ahead and do f of 2. Okay, that is going to be the cube root of 2. Okay, so g of 2, f of 2 minus 1, which is equal to f of 1, which is equal to 1. Okay, so I actually highlighted the wrong couple points. I actually wanted to do just 0, 1, and 2. Okay, so let's look at 0, 1, and 2. And in particular, I want to look at these values. Okay, so I want everybody to notice this. When x is 0, right? When x is 0, that is the same thing as f of -1, which is -1. Okay? When x is 0, g of 0 is going to be the same thing as f of -1, which is -1. So if you just take a look at bare minimum, the outputs for the x and the y values, right? We have that at x equals 0, y is equal to -1. Okay? So that point right there. Okay? Next one. When x is 1, that is the equivalent as f of 0, which is 0. When x is 1, that is the equivalent of f sub 0, which is equal to 0. So at bare minimum again, right? When x is 1, my y value is 0. Bam. Okay? Okay. Moving on to the next point. When x is 2, it is the same as f of 1, which is 1. Again, at face value, right, that should be my y value. At x equal 2, my y is 1, okay? But there's a reason why I've been sort of still referring to the f of x values, right? Okay? To take a look, this point, let me actually start with the bottom point down here. This point was this one moved over one, right? This point was this point moved over one. This point is this point moved over one. Okay, hopefully you guys see the pattern. It's moving over. Okay, so my new graph is actually going to be looking something like this. Don't make fun of me. Don't make fun of me, I swear. Please, please, please. Whoosh. There we go. That's a little better. Whoosh. Okay. In particular, right? You took a look because of the values that we have, right? This got scooted over that way. Okay. That is what this -1 does. Okay. Okay. So altogether, right? If you have a -1 like this, okay, then what you are guaranteed is the horizontal shift. Now, it's going to be opposite of that sign. Okay, just keep that in mind. Notice that it's a -1, so you moved it toward the positives. Okay, and the same rule works in reverse. Okay, okay, so here we go. Both of these functions are transformations of a base function from our toolkits. That right there. Okay, so both of these functions are some x squared stuff. Got it? Okay, look at your toolkit functions and you can find the x squared function. And what I'm going to do is I'm going to give you guys the solutions down below for both of these functions using just solely transformations. Got it? Okay, so vanilla, regular, parabola sort of does this right here. Does that make sense? So the little vertex, the little bottom end goes down there. So it goes whoosh like that, more or less, right? Okay. This gets moved to get this graph right here. Yes. In particular, what I'm going to look at is this point right here. It's called the vertex. We'll learn a little bit more about the vertex a little later. But for now, I'm going to look at that function, right? Okay. If we look at the base function and this one, we can see that it got moved over by 3 and moved up by 1. So this function, f of x, is going to be x minus 3 squared plus 1. And we are done. Okay, so let me review really quick. That minus 3, remember how the horizontal shift worked, right? It's opposite of the sign. If I want to move it toward the positives, it's a minus something, right? So vice versa, if I want to move it toward the minuses, I need to do plus something, okay? And then the plus 1, that works out just as normal, okay? This one, same idea. I'm looking at this point right here. That's sort of like the vertex, right? Okay, the point moved toward the negatives by 2, down 1. So this is going to be x plus 2 squared minus 1. And we are done. That is how you do transformations, at least the basic one for now. Okay. With the graphs that I gave you on in that packet, okay, with the graphs and the tables and the domains and ranges, right? You can grab all of those, do exactly what we did here, and at least get a nice picture of a graph in your mind. You don't need to do anything through Desmos, okay? Okay, first set of quick checks for this section is coming up. We'll do these in class, like I said before, okay? Like I said, those transformations work the same, okay? However you want to use them. Okay, so for example, here's another one that's in your packets. Okay, suppose that we have the function of the absolute value. Okay, that's this thing right here that looks like a little v. Okay, we haven't done the absolute value yet, but here's the graph of it. That's actually next section. Okay, suppose that I wanted to graph h of x, which is this. Okay, hopefully you guys already see the transformation. So we are trying to graph this. Not parentheses. Bar. There we go. We're trying to graph this thing. Okay. Hopefully you guys see, right? Since it's the positive inside with the x, I'm going to move it toward the negatives by 1, down 3. Okay. Okay. And the way that I would do that is this. And this goes for any graph that you can think of. Okay. I'm going to grab some nice points. Okay. You see all these points that I'm picking out on the original. Okay. I grab every one of those points and I'm going to move them to the left 1, down 3, each one. Okay. Now, obviously, you don't have to do each one, right? I think usually, for the most part, you grab the vertexy one, right? I think you can move that one and then figure out the pattern from there, if that makes a little bit more sense. Got it? Okay, so I'm going to do the new points in purple. This point right here, the bottom of my V, I need to move over to the left 1 and down 3. So the left 1, down 3, here it is, right? And hopefully you guys see it's up 1 over 1, up 1 over 1, up. So from here, up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1, la-di-da-di-da, right? Up 1 over 1 in the other direction, up 1 over 1 in the other direction, bam, bam. Hopefully you guys see. So my new graph is this. Whoosh. Ugh. Don't make fun of me. Don't make fun of me. I'm trying here. There we go. Boom. Cool. Awesome. Okay. Next one. Reflections about an axis. Okay. So again, right, when you see these kinds of things in your in a function, right, this should automatically prompt you to do something. Okay, well, this should prompt you to automatically recognize that something's going to be visible on the graph. Okay, so there are 2 reflections here that I'm going to do. This one and this one. Okay, So the first one is just when the negative is out front. Okay, when the negative is out front. Okay? If you want to work through the table, be my guest. Okay, but it's much simpler to see it through a graph. Okay. What this thing is doing, right, is if you take a look at the function itself, the original, which in my case is this one, right, for this example, it is grabbing the y values and turning them negative. Does that make sense? The x values stay the same. It's just the y values get turned negative. So what happens to a graph when you do that? It all completely flips across the x-axis. Okay, so our new graph is going to do this now. So instead of this point, since it's already 0, -0 is still 0. Okay, but the next couple points, that one and this one. Okay, when x is 1, y is 1 for the original, right? So when the negative gets introduced, that's going to be down here. Actually, I'm going to do it in purple to keep with the colors. There we go. Okay. Next point, when x is 4, the square root of 4 is 2. So that's where that one comes from, right? But with the negative in it, right, it's now supposed to be -2. So bam, right there, right? So our new graph is going to be that. So this is going to be negative s of t. There we are. You see how it's called the vertical reflection? You just flip it. Boom. Okay. Next one. Okay. Notice for this next one, right? The inside, the t has the negative now, right? You see that? The t has the negative. Okay. So before, right, over in this one, the x's stayed the same. The y got flipped, right? In this one, the horizontal one, it's the x values now that are getting uh, flipped, right? So instead of going 1, 2, 3, 4, 5, right? Now it's going -1, -2, -3, -5, right? So again, I'm going to look at the same 3 points. This one, this one, this one, okay? And what's going to happen is going to be a horizontal reflection about the y-axis. So then instead of that, it's going to be, this point gets to stay, right? But this one moves here, this one moves to here, and we have our new graph. Boom. There we are. Okay, so this is s of -t. Okay. Okay. So looking at these two, just how we have them, right? You can now combine these with the other ones that we did with the horizontal and vertical shifts, right? That's what Quick Check 2 deals with. Okay. So I'm stacking one more transformation on you. Okay. But the other two were simple enough. Okay. All right. Moving on. Even and odd functions. There are certain functions that have nice properties, okay? Functions that are even and functions that are odd, right, are pretty useful properties for functions to have, okay? So that's what we're going to look at in here, okay? An even function, right, is when a function does this, okay? When f of x is equal to f of -x, okay? An odd function is when your function does this. Okay. I don't like these definitions. I am keeping these definitions solely because they are in the textbook that we're using. Okay. The method that I like much more is this, and they're equivalent. Okay. F of x and f of -x is equal to minus f of x. There we go. Okay. These two are the ones that I like better. Okay. Because you can explain them a little better using your functions notation. Okay. So for example, right, this first one, a function is called even, right, if the negative input is the exact same as the positive input. Okay, that's where that negative, the f of negative x equal f of x come from. So it doesn't matter whether you plug in the positive x value or the negative x value, both of the values are going to be the same. Okay. Okay. A function is called odd, right, if it does this. Okay. Functions that are odd, right? If you plug in the negative x value, it is the same as the positive x value, but negative. I know that sounds weird. Okay. Okay. Uh, on a graph, on a graph, even functions are said to be symmetric about the y-axis. What does this mean? You get to flip it sort of vertically. So basically, you can draw this graph on a piece of paper, right? You can draw this graph on a piece of paper and flip that piece of paper over, right? And you have the exact same graph. Okay. Likewise, for an odd function, it is what's called symmetric about the origin. So basically saying you can draw your graph, right? You can flip it hot dog style and hamburger style. You can flip the paper that your graph is on, hot dog style and hamburger style, and you still have the same graph. Okay. If it's neither one of these, then we say it's neither. Okay. So let me give you guys a little bit of an example for how. Okay. Okay. These three graphs right here. Okay. Let me actually start with this middle one right here. Okay. So notice that this graph right here, the absolute value, okay, pretend you have to draw it on a piece of paper. Okay. Pretend you draw a V on a piece of paper, right? Okay. If you grab this piece of paper that has this V on it and you flip it hot dog style, so basically grab the long edge of the paper and flip it over to the other side, right? You still have the same shape, okay? That means that this graph is even. That is an even function, okay? Okay. Next one that I want to do, that one, okay? The cubic function, the x cubed, okay? Notice that if you grab this function and slap it on a piece of paper, right? And you flip it, like I said, if you flip it hot dog style and hamburger style, so if you flip it along the long edge and flip it along the short edge after that, okay, you get the same graph, okay? Because of that, this is odd. I should do this one as green too. Oh, it should be. Okay, there we go. Okay, and then hopefully you guys see where this last one goes. You can't do anything with this one, right? You're not going to get the same graph any which way, right? Since you're not going to get something that flips about the y-axis and you're not going to get something that's flipped about the origin, this is neither. Okay. Highlight green. Okay, there we go. This is a neither. Okay, all right, moving on. So we know what odd, even, neither looks like on a graph, right? How do we determine said stuff from functions themselves? Okay, that's where the other two, sorry, let me scroll up. That's where these come in. Okay, here's another reason why I like how this, here's another reason why I like this definition, the one that I've circled, rather than the one that from the textbook. Okay, like I said, they're equivalent. Okay, so in the ones that I just circled, this one, right? You always start off with plugging in negative x. Okay, it's the outcome that dictates whether you have odd or even. Okay, so let me show you guys what I mean. Suppose I have these three functions right here. I want to determine whether they're odd, even, or neither. You can go ahead and throw these into Desmos and double check them that way. That's perfectly fine. I'm going to do it the algebraic. Okay. Okay. So I always start with f of negative x. I am always going to plug in negative x into my original function. Okay. So let me actually rewrite that. Okay. So I'm going to start with rewriting it. Okay. Minus x to the fifth plus a minus x. Okay. I'm going to try to simplify this. Okay. Carry out the multiplication here. So negative x to the fifth is negative x times negative x times negative x times negative x times negative x. So all, negative x multiplied by each other 5 times. If you do the multiplication right, you get minus x to the fifth. And then plus a minus, the negative takes over, so you get left with that, minus x. Okay? All right. So now, this is the outcome. Okay? The original is x to the fifth plus x, right? And negative f of x. I'm writing these down just for reference. I mean, there's nothing wrong with that, right? Minus x to the fifth plus, whoops, not plus 5, plus x. If I distribute this negative, minus x to the fifth minus x. Okay. I am looking at this outcome, right? Okay. It is not equal to the original, so it is not even. But, okay, but you guys do see that it is equal to the negative f of x, right? Since both of these are equal, right? Since this and this are equal, right? We get to say that this is odd. Okay, that was the definition. Let me scroll back up. That was this definition right here. That was the odd. That the negative, that f of negative x is equal to the negative of f of x. Got it? Okay. Let's move on. So always, for the second one, for all of these, right? Always start with plugging in negative x, okay? 2 negative x minus negative x squared. 2 times negative x, that's going to be negative 2x, and it's going to be minus negative x squared. That's going to be negative x times negative x. So this is still going to be a positive x squared. Just keep in mind, distribute your negatives appropriately. This negative that's still here is this negative right here. Okay, just keep that in mind when you're actually doing out the multiplication. Okay, let me do my original. So f of x, the original, right, is 2x minus x squared. I'm just writing these down for reference's sake, right? Minus 2x minus x squared. And that, if I distribute the negative, right, minus 2x plus x squared. Okay, this is my result from plugging in the negative x, right? Okay, it is not equal to the original, so it is not even. Okay, and if you take a look at the other one, right, the negative f of x, it is not equal to that one either, right? So between both of these, let me get that highlight out the way. There we go. Between both of these, right? Between that one and that one, right? These are not equal, right? So this one is neither. So that one was odd. This one was neither. Okay, last one. Hopefully you guys see what's going to happen. Yeah. Okay. F of negative x. Always start with f of negative x, right? 1 minus x to the fourth. This is going to be 1 minus, so minus x to the fourth, that's going to be minus x times minus x times minus x times minus x, right? And that's going to be positive x to the fourth. Okay, so this negative is this negative. It turns out the negative that's inside with the parentheses, it ended up disappearing because of the multiplication. Okay. F of x is 1 minus x to the fourth. I know I don't need to write this down. I'm just doing it just for reference's sake, right? F of x negative minus 1 minus x to the fourth, which is equal to minus 1 plus x to the fourth. Okay, here's the result from my computation when I plugged in minus x, right? Okay, it is not equal to this one, so it is not odd, but thankfully, right, you guys notice it is equal to the original. So we have even. Done. Okay, cool. Quick checks are coming up. We'll do these in class so we can work out our algebra. Last thing I want to cover, and then we'll do a quick bit of a review for this entire section, is the vertical stretches and compressions and the horizontal stretches and compressions. Okay, so suppose you have, so in both of these, okay, notice that this blue one in the middle is sort of like my base function. That's my f of x, right? Okay, same thing here. This blue one right here is my base function, right? Got it? Okay. 2 times f of x, that's going to stretch it vertically like that, like this right here, like the green. Okay. 0.5, okay, compresses it. That's the red one that's down below. Got it? Okay. So in general, for this, for the vertical stretch, right? If we have a, right, bigger than 1, right, it's a stretch. If a is less than 1, right, we compress it, we squish it down. Okay. Cool. Okay. It's kind of reversed for the horizontal stretch. Okay. So notice this one, the 2 is inside with the x. Got it? Okay. That squished it this way. We call this the horizontal compression. Okay. And then this one, that one's 0.5 x squared. Okay. That is the horizontal stretch. Okay. So for this one, if b is bigger than 1, right? And this b is bigger than 1. Oh, compress. And when b is less than 1, we have a stretch. Okay. Now, I haven't shown you guys, actually, let me do that. When you have over here, a f of x. Okay. And over here, you have f of b times x. Okay. When your b falls greater than 1, you have a compression. So you compress it horizontally in this case, right? And when your b is less than 1, right, you've got a stretch. It's going to stretch out. Okay. Those same things work backwards for the vertical stretch. Okay. Okay. So let me move here. Next example. Absolute value, we know what that one looks like, right? We're going to draw two graphs. H of x, which is 3 times f of x, and then we're going to draw this one, g of x, which is 3 times, g of x, which is f of 3x. Okay, so here we go. The way that we graph this, again, I'm going to use the same couple points. 1, 2, 3, and then 1, 2, 3. These 3 points, okay? I know this is going to sound weird, okay? At least one of them is going to sound real weird, okay? To do h of x, and I'm actually going to do color coding thing. I'm going to do this one in purple, okay? To do h of x, I'm going to grab my y values and multiply them by 3. Okay? I'm going to grab my y values and multiply them by 3. So my y value here is 1. This should be now 3. Okay? My next one, my y value is 2 times 3 is 6. So my 2 is going to go all the way up to 6. The 1 for 3 goes up to 9. And hopefully you guys see where the rest of these go. Boom. Boom. Okay. This one's the one that's going to sound weird. I'm going to do it in my nice hot pink here. Okay. When you have a 3 inside, okay, you're going to grab your x values and divide them by 3. Okay. So for those, I'm actually going to be using these points right here. So this one, and this one. Okay. This one doesn't move, so it gets to stay there, right? But the 1 for 3, my x value is going to divide by 3, so it's going to move over 1. So it's going to be this one. So instead of here, it's going to go here. And then the same thing for this other point, it goes down. Okay, so lo and behold, both of these functions are exactly the same. Both of these functions are exactly the same. Okay, so there is a way to get a vertical compression to look like a horizontal stretch, and vice versa. Okay. Okay. Quick checks come up after this. This is a nice table to sort of review everything that we did. Okay. What we have here is the mathematical operations and how it affects the graph. Okay. These. That is our vertical stretch. That is our vertical shift. The other one, the one below it, is a horizontal shift. Vertical reflection, horizontal reflection, vertical stretch and compression, and horizontal stretch and compression. Okay? For the most part, for now, don't worry about this one. Okay? We're going to concentrate on the first handful, the ones above it. Okay? We get to see a lot more of the BX when we move into our trig stuff. Okay, when we start doing sines, cosines, and tangents. So for right now, don't worry about it. But I do want to cover those first couple that are above it. Okay, and I mean this table is nice and all. You can remember these. You can memorize them. Okay, and reason why this is so helpful, right? And this is the reason why I like to do this. I'm going to actually do the base one, and I like to do it this way: plus or minus a x minus h squared plus k. There are 1, 2, 3, 4 important things here, right? Okay. Actually, let me scroll up here. This one. Don't worry about this one either. Same thing, we'll move on. We'll see the horizontal reflection in trig once we get there, okay? These are the ones that I want to concentrate on, okay? So hopefully you guys see what each one of these does, okay? The plus or minus is, and I'm gonna keep my hot pink, the vertical flip, okay? If it's positive, it stays facing the original direction, right? If it's negative, you flip it, okay? The A is gonna be the vertical stretch, okay? The H is going to be the horizontal shift, and it's going to be opposite. Whoops. It's going to be opposite of whatever sign that's there. So remember, if it's negative, you move it toward the positive. If it's positive, move it toward the negative, right? And then the plus K at the very end, that's going to be your vertical shift according to the sign. Got it? Okay, so if it's plus 3, you move it up 3. If it's negative 5, you move it down 5. Okay? And the reason why I like to do it this way better, okay, is because of this. F of x plus or minus a square root x minus h plus k. F of x is equal to plus or minus a absolute value x minus h plus k. F of x is equal to plus or minus a x minus h cubed plus k. F of x is equal to plus or minus a square root x minus h plus k. Okay? If you know what one of these, if you can remember just this one, if you remember just this one down here, right? You remember just that one, you know what the rest do. Okay? All you need is the basic graph for them. And I have a repeat there. There we go. Okay? So once you know one of them, you know what all the rest do. Okay? That's so nice about, that's the thing that's so nice about transformations, that once you know one of them, you know them all. Okay? All right, after this, it's lecture questions. If you have any questions on these, ask me during class time, or my office hours in the tutoring center, okay? Besides that, happy studying.